Hello students, good morning. See, in a previous video we have seen the information about our equation of motion, that equation number 2. Two equations we have already seen in a previous two videos. See, these equations are discovered by scientist Newton. The scientist found a relation between motion, acceleration, velocity, displacement and time, and by collecting all these factors he was discovered the three equations. In that two equations we have already seen. In this video we are going to learn the equation number 3, that is nothing but the equation of motion using graphical method. For these three equations, same graph we are going to use or we are going to learn. See, in a previous video I have told you that don't change the sequence of these equations, because equation number 3 depend on equation number 2 and equation number 2 is depend on equation number 1. So don't change the sequence of that equations. In this video we are going to learn the equation number 3 is nothing but v square is equal to u square plus 2s. How to getting this equation? See, here is the v square is equal to u square plus 2as. Here is the s, means here is also s is nothing but, I have already told you, s is nothing but the distance covered by an object. See, here is the graphical representation and all of you know that how the graphical representation. The objects start to moving from point A to point B. At that time initial velocity u, final velocity v to reach the point C. After that, for the consideration we have drawn a line here and giving the names D and E. Like this graphical representation for the equation. In equation first we have seen how the equation number 1 we get. In equation 2 we are consider the area of quadrangle or rectangle. See, in this video or in this equation we are also going to calculate the distance, and when you want to calculate distance there is always a symbol s. And how to calculate the distance? We consider the area of any section. In a previous video we have considered the area of rectangle. In this video we are going to consider the area of not rectangle, same rectangle, but we are going to change the name, that is nothing but the trapezium. We are consider here the area of trapezium, same rectangle ABDO. See, here is the object moving or covered, the distance covered by object, the object covered distance is how much distance? S distance. Therefore S is the distance. Here is the S. See here we consider, if we want to calculate the distance, we consider the area of any section. In this equation we are going to consider the area of trapezium, same rectangle we are going to consider as a trapezium. Which rectangle? See, rectangle or trapezium ABDO. Then the area of trapezium ABDO is what is? S is equal to area of trapezium ABDO is nothing but 1/2 into sum of lengths of parallel sides into distance covered by the parallel sides. See here what I told here. I have told you that is the area of trapezium ABDO. Area of trapezium ABDO. Okay. The area of this trapezium is equal to, or S is equal to, what is the formula for area of trapezium ABDO? Is the 1/2 into sum of length of parallel side into distance covered by parallel side. So the next equation becomes 1/2 into sum of lengths of parallel sides. Which sides are parallel? See, AO plus BD. Okay, AO and BD, these are the parallel sides. Okay, and the distance covered by the parallel side is the nothing but the OD. See, are you getting this? See, 1/2 into AO and BD. AO and BD is what? Is the lengths of parallel side, and OD is what? Distance covered by these trapezium. Okay. Now, what is the value of these AO, BD and OD? See here, S is equal to 1/2 into, what is AO? AO is nothing but the initial velocity. This value is known as AO. Means what is the value of AO? Value of AO is U. Plus, what is the value of BD? This is the BD, and value of BD is the V. That is nothing but the final velocity. Therefore, I write here V into, what is OD? OD. OD is nothing but the time. Therefore, I write here time. Are you getting this? Now, see, but the object moving in a accelerated motion. Okay, object is moving here in accelerated motion. Therefore, I write here, what is the formula for acceleration? A is equal to V minus U divided by T. I write here the equation becomes, or I will rearrange the equation here. That is nothing but the T is equal to V minus U divided by A. Which value we are getting here? The value of T. This value of T putting in this put in this equation number 1. See, what is the equation number 2? The equation number 2 becomes S is equal to 1/2 into U plus V into, what is the value of T? This is the value of T. From which equation? From this equation, the value of T becomes V minus U divided by A. Okay. Now, S is equal to, these two are gathering together. The equation becomes U plus V, or V plus U, you write anything, into V minus U divided by 2A. Okay, I write here V plus U. Now, by equating this equation, 2AS is equal to, what we getting here? V plus U and V minus U. All of you know that. See, I write here the equation. What is the last equation? 2AS is equal to V plus U and V minus U. All of you know that the value of V plus U and V minus U is nothing but the, which is equal to V square minus U square. Therefore, the equation becomes 2AS, which is equal to V square minus U square. See, this equation is like this equation. Near about approximately both equations are same. See, by rearranging this equation, this value getting here, V square is equal to U square plus 2AS, and this is known as equation of motion using graphical method, and this is the equation number 3rd, which discovered by scientist Newton, which describing the relation between, which relation between? The relation between displacement and time. How we calculate here the distance? By considering the area of trapezium. And what is the formula for area of trapezium? Which is equal to, S is equal to 1/2 into sum of lengths of parallel side and into distance covered by parallel side. Like this, we have seen the in equation number 3, that is nothing but the equation of motion by using graphical method, which describing the relation between displacement and time. The displacement and time, how they are related with each other, they are describing in this equation. We will stop here.